when it is inappropriate to use the GSI classification. The Geological Strength Index is designed to estimate rock mass properties by treating the rock as a mechanical continuum. However, there are several specific geological and engineering conditions where its application is inappropriate or meaningless. If the rock mass has a clearly defined dominant structural orientation or failure is governed by shear strength of a specific discontinuity, such as a single fault or shear zone, rather than the mass itself, the GSI is considered meaningless. Second is structurally controlled stability. It should not be applied to excavations in strong hard rock with few discontinuities when the spacing of these discontinuities is similar to the dimension of the tunnel or the slope. In these cases, stability is dictated by the three-dimensional geometry of the intersecting discontinuities and the excavation's free faces rather than the properties of the rock mass as a whole. In hard rock at greater depths, typically 1000 meters or more, the rock mass structure becomes so tight that it behaves like intact rock. Under these conditions, the failure process is dominated by brittle fracture initiation, such as spalling or rock burst, rather than structural discontinuities, making the GSI system no longer meaningful. Soil-like materials: if weathering has progressed to the point that the original rock structure and discontinuities are lost, the material must be assessed as a soil and the GSI system no longer applies. Loose conglomerates: the sources specifically note that GSI charts should not be used for loose conglomerates. These materials should be treated as weakly cemented river gravels. Limits of quantification: while some engineers attempt to quantify GSI with numbers, this approach is not valid in tectonically disturbed rock mass where the structural fabric is destroyed. It is also inappropriate where the rock mass behavior is no longer controlled by the sliding and the rotation of pieces but by the failure of the intact rock pieces themselves.